Coochie, 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 coochie. Who's the cute baby? Whoa. Wait a minute. Welcome to Dr. B in 3.
This or that? This?
Okay. It seems like every day now there's a big headline in the news about some huge scientific finding that seemingly changes everything. Dogs can help you live longer. Watching too much TV can kill you. Facebook users get worse grades in college. Wine helps your heart. Wine shrinks your brain. Wine helps you live longer. Wine makes you die sooner. Whoa, stop. Sure, these news stories are all based on actual scientific studies. But here's the problem. The headlines all suffer from a very common mistake we humans make when we see two related things. The mistake is that we assume that one thing causes the other. But here's the deal. Just because a study found some correlation between dog ownership and extended human lifespan does not mean that your dog is causing you to live longer. Why not? Because as the authors themselves pointed out, the studies didn't take all variables into consideration. For example, in this case, they didn't consider diet, smoking habits, or financial well-being of the owners, just to name a few. And therein lies the issue. I know we all want to believe that Fido is making us live longer, but at the end of the day, the results are still inconclusive. Correlation does not imply causation. I'll say it again. Correlation does not imply causation. If you're wondering what the heck I'm talking about, stick around and let's dig into it. What do correlation and causation mean? How are they different? And why does it matter? Okay, let's start with some definitions. When two things are related, we say that there is a correlation between those two things. Heavy snowfalls are correlated with snow shovel sales. When two things are correlated, it may also be the case that one thing caused the other. Heavy snowfalls do indeed tend to cause an uptick in snow shovel sales. But sometimes there's no causation at all. The other day, I walked out of my house and it immediately started to rain. The timing of me leaving the house and it starting to rain were correlated. Me leaving the house had nothing to do with it starting to rain. That brings me to causation. Just like it sounds, causation means that one thing caused the other thing. It made the other thing happen. Rain clouds cause rain. So, quite simply, causation and correlation are two different things. Let's look at a few examples. For decades, data from Berlin showed a significant correlation between the stork population around the city and the increase in out-of-hospital births. So, have we been wrong all this time? Do storks really deliver babies? No, they don't. This is an example of correlation, but not causation. The truth is, sometimes correlations are entirely coincidental. The number of storks in Berlin happen to correlate with out-of-hospital births, and the amount of mozzarella cheese consumed per person per year happens to correlate with the number of civil engineering doctorates awarded that year. Correlation does not imply causation. Now, sometimes there is a connection, like in this example. Did you know that the amount of ice cream sold in the United States correlates with the number of sunburns in the United States? So, if you believe that correlation implies causation, you might be concerned that those tasty ice cream cones are doing something to our skin to make it more susceptible to sunburn. Yikes! Should we stop eating ice cream? But wait, back up a second and think about it. Hot sunny weather makes us much more likely to buy ice cream. And that sunny weather also gives us a sunburn when we're outside more wearing less bulky clothes. So, although it is true that the amount of ice cream sold is correlated with the number of sunburns, one does not cause the other. In fact, there's a third variable here, the weather. Correlation does not imply causation. Now listen, these silly correlations may seem harmless, but there can be great danger in confusing correlation with causation. In 1999, a team of researchers found that children whose parents left the lights on at night were more likely to be nearsighted when they grew up. They found a correlation. Very quickly, however, popular media confused correlation with causation. They assumed that those lights caused the nearsightedness. They began to criticize parents who left lights on at night. Some went as far to call it an abusive behavior. But you see, the condition of myopia or nearsightedness is not caused by night lights. In fact, myopia is genetic. So if your parents are nearsighted and therefore perhaps accustomed to leaving lights on at night to get around, then you also are more likely to be nearsighted. But because of your DNA and not because of the night lights. And in this case, these assumptions led to some very harmful and misleading accusations. Correlation does not imply causation. My point here is this. It's easy to make assumptions that one thing causes another. And media outlets often make those assumptions for us with their sensationalized clickbait headlines. But as consumers of information, we need to take some personal responsibility. And a good start is looking to the original source of information rather than blindly believing those clickbait headlines. And by the way, since correlation does not imply causation, you may be wondering, what does imply causation? Well, the only real way to determine causation is through rigorous experimentation. In fact, a big part of being a scientist is meticulously designing experiments to determine whether two things are related through causation or just correlation. Like, for example, did that drug help the cancer patient in the trial, or were other factors at play? Correlation happens all the time, and when it does, it is certainly worth taking a closer look. But the only real way to determine causation is through one or more carefully designed experiments. And that's another Dr. B in 3. If you like this video, remember to like, subscribe, and comment below.